All right, just a little bit of reminder from what we talked about on Tuesday as far as the angle measurement that...
What's it supposed to be? Like in my shirt.
So remember that regardless of whatever the angle is, whenever it's on the unit circle, we had the 6 different trig functions of a unit circle that whenever... regardless of however your angle tracks, whether in a positive, whenever you go in a positive direction, and we'll talk about whenever it goes in a negative direction today, that your sine of whatever your angle is going to be equal to your y value. So wherever your y coordinate is, your cosine value of your angle, whether it be in degrees or radians, is going to be whatever your x value is. And then tangent is just sine over cosine or y over x. And then your sister functions, or what we're calling our sister functions, is like cosecant, secant, and tangent, where it's just its sister function, like cosecant, is just the reciprocal of sine. Secant is the reciprocal of x or of cosine. And then cotangent is just the reciprocal of tangent. So whenever we use this, one of the big parts of like our exact values of trig functions at pi over 4. Pi over 4 is one that's going to be frequently used. Biggest thing that I can try to help you simplify any of this down to is really all we're doing with a unit circle is just cutting the circle basically into slices. Okay? We use pi, so we cut slices of pie up, or we cut pizza in by the slice. Okay? As long as you don't cut it into squares and you cut it the right way, okay, and you actually have it in triangles, okay, because it tastes different. Just ask my son. Okay? It's better if it's in triangles. It's terrible if it's in squares. Okay? That all you're doing is just cutting that circle in a certain way. Okay? Whenever we cut it into, whenever we use 4 slices or 4 cuts, okay, we're going to use pi over 4. Okay? Whenever we use 6 cuts, we're going to use pi over 6. Whenever we use 2 cuts, we're going to use pi over 2. Okay? However many cuts we make, if you think about it, if that's how or if we cut it into, if we use 3 cuts, okay, then we're going to use pi over 3. However many cuts we make is all dependent on how many sections, like, if you make 2 cuts, how many actual pieces of pie or pizza do you have? 4. Okay? It's doing the same thing to the circle. Okay? The one constant with any cut or any slice that you make, where does your first cut always go? Down the middle, right? Now, your down the middle may be different, but for us, our down the middle is always going to be the x-axis. Okay, because we can always spin that pizza basically on the x-axis and put it there, and then go from there. Okay, so whenever we talk about trig functions, don't let it overcomplicate things just because there's a pi somewhere. It's really the same thing. It's basically, if you think about walking that circle, okay, if that circle is, pi is just a measurement. It's just a number. Okay, it's just a symbol that we use for a number that we never really care that it's 3.14592, whatever. Okay, we're just calling it pi. If you think about that circle, if we walk basically that full circle and we walk 2 miles, okay, or 2 pi in distance, before we go, if we go 1 full revolution, okay, again, we've talked about there are different stopping points. We can get to the same spot if we walk in a negative direction or in an opposite direction. So from what you picked up in your geometry class, one of the few things that you probably remember about trig was probably this right here. Okay, because the trig that you know is right triangle trig, right? Okay, with right triangle trig, whenever you were in geometry, you had two special right triangles. You had a 45-45-90 triangle and you had a 30-60-90 triangle. One of the frequently used, okay, these are the two main ones that you're going to use. Okay, we have everything we've already talked about, like pi over 2, pi, 3 pi over 2, where it's on the axis. What we're going to get into are all the special spots of a special right triangle. Whenever our angle measurement is 45 degrees, whenever it is 30 degrees, or whenever it's 60 degrees. Okay, we've talked about before, or whenever we started with the unit circle and stuff like that, the unit circle, remember, is just a huge compilation of right triangles. Now, knowing that, we have two special ones that we picked up in geometry a couple years ago, probably. So whenever we do this, whenever we talk about special right triangles and we talk about frequently used trig functions, pi over 4 is one of those trig functions. Pi over 4 is going to be one of those that's going to be with a 45-45-90 triangle. If you think about it, whenever we cut a 90-degree angle in half, what's it going to cut it into? 45 degrees. Okay. Now, whenever we deal with the 30-60-90, that depends on where your angle lies and how that's going to fit. Okay. The one thing that it will always do is it will always make the hypotenuse, remember, is always your long side. Okay. So your hypotenuse is always your long side. Your hypotenuse is always the radius. So for both of these triangles, what is the pi over 2 and the 2 pi, or excuse me, 2x? What are both of those equal to? If it's the same thing as the radius in the unit circle, what's the radius of the unit circle? How much? Unit circle has a radius of 1. So whenever we deal with these exact trig functions, okay, or exact values of trig functions, and we're talking about pi over 4, okay, pi over 4 is going to deal with the 45-45-90. Okay, 30-60-90 is going to be your pi over 3. It's going to be your pi over 3 or pi over 6, depending on which one, the way that that triangle is facing. Okay, depending on how that triangle is, how you have to draw it, basically. So whenever we're just going to talk about the 45-45-90 triangle. Okay, a couple different ways that we can figure out, hopefully, what x is. Okay, since the hypotenuse is always equal to 1, okay, or at least whenever we're dealing with the unit circle, it's equal to 1. We can either set 1 equal to x times the square root of 2, or you can use your trig functions up here. It's really up to you. It's going to give you the same thing. Okay? So we can figure out what our x and what our y values are going to be. Okay? Because regardless, in a 45-45-90 triangle, if here's the center of my circle and here's the point on the circle, if that's x and y or whatever my coordinate is, what do you know about those two numbers? Any ideas? What do you notice down here? Or if we call it A and B as far as my coordinate. What do you notice about, what do you think is going to happen about those two values? They're going to be the same. Okay? So whenever we do pi over 4 and we have exact values, those are going to be the same. These are going to be the same. Okay? Your sine and your cosine values are going to be the same value, the same exact value. That's what makes it easy. Okay? Because your length of one side is going to be the same as the length of the other because it's a 45, 45, 90 triangle. So how do we figure out what that value is? Well, a couple different ways. You can either, like I said earlier, you can go 1 equals x times the square root of 2. And you can solve for x. You can figure out what your value is. It's completely up to you. Okay, this probably is the easiest way, to be perfectly honest with you. Because what do I need to do to both sides to get x by itself? Can I just divide by the square root of 2? Now I'm going to change the order and I'm going to have x equals 1 over the square root of 2. Now can I leave a radical in the bottom side? No, so how do I get rid of it? Multiply by the square root of 2 over the square root of 2, right? Especially if you don't remember your trick. So the top side is just going to be the square root of 2 over 2. So that means x down here is the square root of 2 over 2. That means the x value here is the square root of 2 over 2. That means if I would have this part on my circle, my coordinate here would be the square root of 2 over 2. So from what we talked about on Tuesday, what is sine of pi over 4? Remember, sine of my angle is equal to y. So what's my y value? Square root of 2 over 2. What's my cosine value? Square root of 2 over 2. Now, the other way of doing that is really just to find, I could use my, I could use what I remember from geometry of opposite over hypotenuse, or I could do tangent and I could do opposite over adjacent. Now, I need to figure out what x is. Okay? If I'm doing sine, okay, for each one, it's going to do the same thing. If I need to know what sine of pi over 4 is, well, here's opposite. Here's my hypotenuse. Now, this is before we find this. I'm doing this before I've already figured out that x is equal to the square root of 2 over 2. Okay, it's like I don't know anything. The only thing I know is that sine is opposite over hypotenuse. So I need to pick one of these values. So I picked the 45. I can't pick the 90. So then if I have sine of 45 or sine of pi over 4, what's the opposite value? Well, it's x. What's the hypotenuse value? It's x over the square root of 2. Or times the square root of 2. What's going to happen to my x's? They're going to cancel. So I have 1 over the square root of 2. It's like I've had this before somewhere. It's amazing. Even the people that are watching Netflix right now can figure that out. So then multiply by the square root of 2 over 2, or square root of 2 over square root of 2, and I'm going to get the same answer. So there were two different ways that I could have found this, and it's still going to give me my same Answer, square root of 2 over 2. I can do the same thing again with cosine. Okay, since these are special right triangles, okay, it's just knowing what they're going to go with and which ones go where. Even if I did cosine of the same angle, if I went with the 45 that's down in the bottom corner, I'm still going to get x over x times the square root of 2, and I'm going to have to do the same thing. Now, since they are special cases, I want to try to remember these cases and not have to do right triangle trig every single time. You can. It's always a possibility. But you don't have to. If you can remember that sine of pi over 4, hey, all the time, every time, square root of 2 over 2. Whatever sine of pi over 4 is, it's going to be the same thing with cosine of pi over 4. Now, tangent's even easier, because what is sine divided by cosine? What is the square root of 2 over 2 divided by the square root of 2 over 2? 1. Again, we could do right triangle trig and take what I have. Remember, that was opposite. This one would be adjacent. So what is x divided by x? 1. Now, the sister functions are going to be a little bit easier. And if you think about it, the sister functions honestly are probably easier than doing the original functions as far as right triangle trig. Because if sine is opposite over hypotenuse, what do you think cosecant is? If sine is opposite over hypotenuse, what is cosecant? Hypotenuse over the opposite. Well, what's the hypotenuse? No? Well, yes, but x times the square root of 2. What's the opposite side length? X. What's going to happen here? Yeah. So what is cosecant of pi over 4? Just the square root of 2. So, knowing what you know, what is secant of pi over 4? Square root of 2. And then the last one, that is still the easiest one, what is the reciprocal of 1? Still 1. Now, I could have done the same thing. I could have taken square root of 2 over 2 and flipped it and had to rationalize everything there. I could have done the same thing. Hey, I could have taken this and went 2 over the square root of 2 and had to rationalize it to get 2 times the square root of 2 over 2. Well, they would have canceled anyway, and I would have gotten the same value down here. I can do the same thing with the 30, 60, 90, with either the 30 side or the 60 side. Hey, but that's going to be your job come Monday whenever we start the unit circle project and do that. Okay. These are ones, especially pi over 3, pi over 4, and pi over 6. And all of those spots, those are the ones that you're going to have to remember, because those are all a part of the unit circle. Okay, because they're the exact cases. They're the special cases. Now, the one thing I do not want to see here is I do not want to see square root of 2 over 2 and you just type it in, or just type in your calculator sine of pi over 4 and you put in 0.707. No. Not gonna do it. Okay, write the exact answer, square root of 2 over 2, or for cosecant, square root of 2. I don't want to see 1.41. I want to see the square root of 2. And then I want to see 1 for tangent, not 1.000. Whenever we talk about even and odd trig functions, okay, remember that whenever we talk about if a function is even or if a function is odd, it's even whenever no matter what value of x that I plug in, if I plug in the negative version, I'm going to get the same y value. Okay, whenever you were in algebra 2, y equals x squared would be an even function, because if I plugged in a positive 4 and I squared it, I would get a positive 16. If I plugged in a negative 4 and I squared negative 4, I would still get a positive 16. My values would still match. Okay? So with this, whenever we talk about even and odd trig functions, okay, cosine is the one that stands on its own. Okay? So since it stands on its own, okay, cosine is always going to be even. Because what does cosine always deal with? What value? Cosine always dealt with was my x, right? So if cosine was my x value, remember, cosine was always x. Sine was always y. Okay? So cosine is always going to be even. Because no matter what, if I leave from the starting point, no matter where I go, in a positive direction or a negative direction, okay? So if I have anything, if I have a, an, or, and I add any angle, if I do the same thing, and if I have the same spot and I subtract the same angle, then my y value will be equal. Or the same, whatever word you want to use. Okay, because if we're always dealing with cosine and dealing with y, if you look back here, or here I can draw it on here. If I go in a positive direction this way, all right, I end up at point P, right? Point P is at x, y, whatever values you want to give it. It doesn't matter. I go in the same direction, or I go in the same distance, but I go in a negative direction. So if I go in that negative direction, I go here. Where's this point at? What do you notice about those values? Did my x value change? No. Did my y value change? Yeah, it's the negative version of it, right? So remember, it's even if no matter which way I go, if I go in a positive direction or a negative direction, that y value didn't stay, that didn't change. It's just stacked right on top of each other. Whereas whenever I deal with the sine function, and even the tangent function, because it's going to deal with sine, the sine function is going to be odd, because if whatever I have and I add that angle, And then if I subtract the same value, whatever angle that is, then my y values are opposite. Oh, it should have been x values up here. I'm sorry. So change that to an x. My fault when I wrote that in. It's going to mean the same thing. Okay? So if I go in a negative value, okay, or a negative direction, it's going to be the same value that I get for a positive direction or a positive angle. Now, since cosine is even, that means secant has to be even, because they are sister functions, right? Same way with sine. Since sine is odd, that means cosecant is odd. Since tangent is odd, cotangent is odd. The only reason tangent is odd is because it has sine in it. That makes sense? So if the sine value is going to be negative, they're going to be opposite of each other, then that means the tangent's going to have to work the same way because it has that value in there. So like if I have cosine of negative pi over 4, okay, we talked about earlier that pi over 4, or cosine of pi over 4, was the square root of 2 over 2. So what's cosine of negative pi then? Do we need to change anything? Do we? If this was negative, it's the same thing as the positive version, right? So instead of pi over 4, we have negative pi over 4. That means those two are going to be the same thing. Now, it's going to be opposite whenever we talk about tangent, because what was tangent of pi over 4? What was it? 1. So tangent of pi over 4 was 1. What do we need to do now? So what is tangent of negative pi over 4? Negative 1. Cosine and secant, if you go in a positive direction or a negative direction, it is not going to change your value. That x value is always going to be the same. But for for sine and tangent and cosecant and cotangent, it's going to be the opposite of whatever your original is. Okay, if your positive is a positive, then your negative is going to be a negative. If your positive is a negative, then your negative is going to be a positive. It's going to be the opposite. Okay? Remember, it doesn't change. Odd is opposite, even is the same.